interrupted, said, "Sir, we cannot. Your charts are not changing," and so I had to go back. So
Yeah.
in
But
the
I thought it was an issue with the Zoom session only, the last one which we had. Uh,
well, no, this was actually another presentation, uh,
okay.
and so it
Sometimes challenges out in today is developing the strength we need. These words, I would like to invite the person who always encourages, guides, and hurdle. Dr.
A pleasant evening to one and all present here.
Our beloved principal, to welcome.
A pleasant evening to one and all present here. It's my pride and privilege to give the welcome address to this august occasion. Today, we are organizing 100th webinar in the banner of Aeronautical Engineering, Nehru Institute of Engineering Technology. Nehru Institute of Engineering Technology is the branch from the tree of Nehru Group of Institutions. We are moving towards the academic excellence, the vision framed by our founder chairman, Sri P.K. Das, molding true citizen for our nation as well as entire world.
Director Aeronautical.
I'm available, sir.
Yeah, okay, sir.
I'm available, sir.
In this regard, this space exploration, when we are speaking about the
Principal sir, please unmute yourself, sir. Please unmute.
Commercial, Mr. George Salazar. I welcome our honorable chief guest, Mr. George Salazar, NASA Johnson Space Center, Human Computer Interface, Technical Discipline Lead, Commercial Crew Program, Displays and Control System Hostel. In spite of Sir busy schedule, Sir accepted a invitation and Sir came here and he will be explored in the area of the space. You are going to explore it. Behalf of our management and faculty members and future engineers, our hearty welcome you. It's my privilege to welcome our respected, our CEO and Secretary, Nehru Group of Institution, Dr. P. Krishna Kumar. In the absence here, I would like to place my gratitude, our Chairman and Secretary, Chairman and Trustee, Dr. Advocate Krishna Das. See, both their support and guidance, we are moving towards the academic excellence. Behalf of our faculty members, our future engineers, our welcome you, sir. I welcome a love and affection with Mr. Samir Sachdeva, founder, Spaceport India Foundation, India. With his support, we are going to organize the joint venture program with the NASA. Big our faculty members, our future engineer, our management, welcome you, sir. I welcome our respected principal of sister concern institution, dean, directors, head of the department, faculty member, our future engineers, participant from our group of institution, other institution. I welcome you all to the great occasion. Thank you.
Thank you, sir, for welcoming our guest. If your actions inspire others to dream more, learn more, and become more, you are a leader. I would like to welcome our leader, Dr. P. Krishna Kumar, CEO and Secretary, Nehru Group of Institutions, to give the presidential address.
Good evening to all. And I feel it is a great blessing and a great memorable day in my life to be part of a great international webinar on space exploration, which is our chief guest is representing NASA, and our Indian counterpart, Mr. Samir sir, also is there with us. I feel it is a great blessing for Nehru Group of Institution, especially Nehru Institute of Engineering Technology, to be able to conduct a program like this under this COVID and pandemic situation. But digital world has created an opportunity to get connected to the entire world, to get information, knowledge from different part of the world, to understand and share the knowledge during this time. I really appreciate both of the great personalities who are sparing their valuable time to enrich our children's knowledge and the faculty fraternity of our NGA group. Most respected chief guest of the day, I feel this is one of the greatest blessing which any institution can have. Our today's chief guest, Mr. George Salazar, NASA's Johnson Space Center, Human Computer Interface Technical Discipline Lead, Commercial Crew Program, Displays and Control. SAR is having more than 3 decades of experience in space exploration. And I'm sure with this rich knowledge and experience, today's webinar will be giving more of insights which an institute like ours from India probably will get once in a while or once in a blue moon, this kind of interaction. I'm so thankful to you, sir. My pranam and my thanks on behalf of management, on behalf of faculty, on behalf of students and entire participants. We bow in front of you and thank you so much for accepting and making this day happen. And our Indian associate who was really inspirational and the person who was the reason behind this great program. I personally feel to say that this is my first time I'm being part of a webinar which is on a space exploration, which always anything above this land, it is always give excitement for any human being. And when it goes beyond our eyes limit, and when it goes to space, I think that is always like an excitement, and which always we read in newspaper, we see from different social media what is happening there, what all things is finding out, and how these things are exploring for the benefit of the society. Most respected Mr. Samir Sachdev, the founder of Spaceport Indian Foundation India. Sir is really a great inspiration for us, because under your guidance and mentorship, I'm sure our aeronautical department and entire NIET or NGI will get more information, more insight about different field of space or aviation or different area where children or the student cannot get it from the curriculum. And most respected my principal, Dr. Manirasan from NIET, Dr. Shankar, Director Aeronautical of NIET, Dr. B.R. Sendil Kumar, Head of the Department of Aeronautical, and Mr. J. Karthikeyan, Assistant Professor, Coordinator of this program, and all respected Head of the Departments, Faculty Fraternities, and Principal of Nehru Institute of Technology, Dr. Alusri, and other family members of NGI who was participating in this webinar, and most important is the students and other participants who are eager to hear from what is how they NASA and other great organization do research and do a lot of contribution for the development of society. I'm sure today's webinar will help all of us to understand what is space exploration is all about and where we stand in 21st century and where we are going to be within few years and what is going to be the space exploration all about and how is going to help our humanity as a whole. I think that will be discussed in length and breadth. I'm sure that will be a great insight for all of us. I once again, on behalf of management, on behalf of faculty fraternity, students, and all others, I extend my sincere thanks and pranam to the chief guest and the guest of honor, Sami sir, for being with us, for being motivating us and sharing your rich knowledge and resources. Thank you so much, and we pray and request all of both of you, sir, to support us and guide us and make us better. Thank you so much.
Well, thank you, sir. It's an honor, and thanks to all for giving us Spaceport India this opportunity. So it's really a pleasure to be here and to listen to you all, seniors, I would say. And definitely we will work together and do something better for our country, for our humankind, and all the kids, for sure.
Thank you so much,
Thank
sir.
you,
Thank you
Samir,
so much.
sir. Thank you, sir. Thank you so much. Before moving on with the session, I would like to give a brief introduction of our chief guest. Mr. George Salazar has over 36 years of experience and is currently serving at NASA's Johnson Space Center as the Human-Computer Interface Technical Discipline Lead to develop advanced human interfaces, as well as serving as the Displays and Control Subsystem Manager for the Commercial Crew Program. He is a part of NASA's SpaceX Demo 2 mission and is into telemetry, communications, speech control, command and data handling, audio, displays and controls, intelligent lighting, project management, and systems engineering. Mr. Salazar has been involved with the design of advanced telemetry, speech recognition, and intelligent systems, of which he has received various patents. He is also the co-founder of the NASA JSC Human Systems Integration Employee Resource Group with the key goal of infusing HSI into the NASA development process. He is also part of further astronaut missions to the moon. With great honor, I welcome Mr. George Salazar to address our online gathering.
George is on mute, I guess. George, can you please unmute yourself?
All right. So, all right, got that. Thank you very much, Samir.
Yeah.
My apologies on that. So let's see. Hopefully, you can see the first chart. Can you see the first chart?
Yes, we are able to.
Yes.
Okay, very good. So I want to thank Spaceport for inviting me to be a speaker. Space exploration is a big topic right now. I have to say that one thing that I try to remind people is that NASA is an acronym for National Aeronautics and Space Administration. So NASA works in aeronautics, which is aerospace, building better jets, understanding how to fly at hypersonic speed through the atmosphere. But space is our big one. And so today's presentation is space exploration and challenges. I have to say that between aeronautics and space, space is a little bit more challenging than aeronautics. And so I'm hoping to share knowledge with you today about some, not everything, because I could spend all day talking about space exploration, but some of the challenges associated with our new mission going to the moon and beyond, and some of the challenges associated with that. But first, I really want to first mention about the brief history of human spaceflight, because human spaceflight, it took a while. It took a while to understand how humans work and operate in space. And it took many, many years for NASA to understand how to build systems to help humans live and work in space. I'm also going to be talking about the current and planned human spaceflight programs, and then human spaceflight mission complexity and risk. This is something sometimes is not advertised to people, is how complex building these systems are for space exploration. And so I'll share a little bit about that and some concluding remarks. So the first up is the brief history of human spaceflight. And so it started back in the early 1960s with the Mercury program. In the very early stages of NASA, we did not know if humans could operate in space. We did not know things like can humans eat in space? Can they sleep in space? What are the effects of gravity on humans or microgravity on humans? And so the first Mercury program included 7 astronauts. They were all military pilots. And the reason they were military pilots is because military pilots understand risk in flying complex systems and complex jet aircraft. And so they were all military pilots, including John Glenn. And so we did several space flights of the Mercury program to find out what does it take to live and operate in space. The systems were not very complicated as far as computer systems. The computer systems were on the ground, and they would compute trajectories and navigation and control and send the commands up to the Mercury capsule. And then in the Gemini program, a few years later, the system got even more complicated. It was flying 2 astronauts. It had an onboard computer, the first ever onboard computer for navigation, but also, more importantly, for rendezvous and docking with another spacecraft. That was going to be important for the Apollo space program, is to dock and rendezvous with another spacecraft. And then the Apollo program came, and that was everything came together, Mercury, Gemini. And so we started to build better human-computer interface systems. We started to understand how to build a extra vehicle activity spacesuit that the astronauts could live and operate on the moon. Unfortunately, things that we trained on the moon, or rather on Earth, with the spacesuit, we found out differently when we finally got to the moon. The center of gravity of the spacesuits was a little bit high, and so if you look at video of astronauts on the moon, they fell a lot. And the reason for that was because the high center of gravity. The new spacesuit that we're developing, the Z4, is going to take care of that problem. And of course, landing a human on the moon. You know, there you see the Apollo lunar lander getting ready to land on the moon. And that was very complex for a human to operate. But we learned through a lot of training how to develop better systems for the astronauts to land on the moon. I have to say that from switches, complexity, Mercury had about 55 switches in a capsule. Gemini had about 250. The Apollo Command Service Module had over 700 switches. And then Space Shuttle, that's the program that I started on. Space Shuttle was a very unique and complex vehicle. It launched like a rocket, it orbited like a satellite, but it returned to Earth like a jet airplane, and so it had three different modes of operation, and it was very complex. It had 5 general purpose computers that controlled the whole space shuttle. And then let's talk about current and planned human spaceflight programs. And so here's the phased approach to Mars. So the first one is what we call Earth-dependent operations. In other words, we have a orbiting space station that's right now up in orbit, about 260 nautical miles. And so it's not too far from Earth. And we call it Earth-dependent because if things go wrong, it doesn't take but maybe a few hours to get people out of the space station and return them back to Earth, but also sending new astronauts to the space station. Like, for example, SpaceX that I'm involved with, they're launching and going to be sending more and more astronauts to space station. Space station requires quite a few astronauts to operate it. You got to have more than 3. If you only have 3, you can only maintain the space station. More than 3, you can actually do more science experiments and stuff like that, because space station is huge, and I'll say that later. Then the next phase is right here in the middle, what I call the proving ground. So the proving ground means that we're going to learn to live and operate on another planet for a long period of time. And of course, the best one for that is the moon. It's only 3 days away, so it's not very difficult per se, to get an emergency vehicle to the moon in case something goes wrong and get the astronauts out of there. Now it starts getting harder when we start going to Mars. Now this is all called Earth independent. In other words, what this means is that you can no longer depend on Earth, to save the astronauts. The astronauts are going to have to use the existing systems that they take with us, and the astronauts' ingenuity and creativity to solve complex problems. That's one of the biggest challenges of going further and further away from Earth. I'll say more about that later in my presentation. Space station right now is huge. It's the size of a football field, about 300 feet, almost 100 meters. And it provides experiments for building new technology and seeing how new technology operates in space, as well as the human beings. We're learning about the microgravity environment, to conduct experiments like astrobiology, astronomy, meteorology, physics, and other experiments. Things that we do here on Earth do not behave the same in the microgravity environment, and we're still learning how that microgravity environment affects us and also affects technology for long periods of time. We're conducting technology experiments, seeing what new technology works and how well it works in space. And more importantly, can it be reliable for a long duration mission to Mars? And then the most important one are humans, conducting human behavior and health experiments. Like right there, you see Scott Kelly that spent over a year on space station to seeing what the effects of microgravity are on the human body. I have to say that he was affected quite a bit by the microgravity environment. It took him a while to recover. It's just some of the factors that we need to understand, because the human body was not designed to live in a microgravity environment. It was designed to live in a 1G environment, the gravity environment that we live in right now. And so we need to understand how we can develop systems, technologies, and such to help astronauts live on another planet for a long period of time. And so here's the Artemis program. The Artemis program is the Return to the Moon program. Interesting enough, it's Artemis and Apollo in Greek mythology. There were brothers and sisters. So Apollo, Artemis was the twin sister of Apollo. And so that's why we call it the Artemis program. And it's going to be a phased approach for going to the lunar surface. So the first thing we're going to do is going to send a spacecraft designed for humans, no humans on there, in the 21st century. In fact, we're looking at within the next couple of years sending the Orion spacecraft to the moon and orbit and to see how the systems behave for the moon environment. And then we're going to send humans to the to orbit the moon later, maybe a couple of years after that. Afterwards, we're going to also be looking at new technology. This is going to be important. It's going to be important to develop new propulsion systems because propulsion is one of the key factors for exploring deep space. On Star Trek and all these scientific sci-fi movies that you see in the on television or in the movies, it shows that they go to other and other solar systems very quickly, but that's not the case. It takes a long time to go in space from one, let's say, from one solar system to another solar system. The distances are very huge. Case in point, the Voyager that did the exploration of the solar system back in the 70s was launched about 1977, and it went, its speed is about 36,000 miles per hour. And just recently, it left the solar system after 40 something years in space, traveling at 36,000 miles per hour, that it finally left our solar system. So that gives you an understanding of the huge distances of space exploration. So we need to come up with better ways of propulsion systems to get us to other places much quicker. And then the first pressurized module delivered to the gateway. The gateway is going to be like the orbiting moon space station, just like space station we have right now orbiting the Earth. We're going to have this gateway that's going to be orbiting the moon 24 hours a day. We're going to have a human landing system. I'm currently getting involved with the human lander system, very much like Apollo's lunar lander, only this one's going to be able to be used over and over again. Send people to the ground and then bring them back up to the orbiting gateway space station and then bring them back down and vice versa. And so the crew missions to Gateway and the lunar surface are going to happen somewhere around 2024. In the meantime, we're gonna want commercial partners to help us explore the moon, and so we're gonna have commercial lunar payload services that, like for example, SpaceX, Orion, the Blue Origins, and other commercial companies. And I'm hoping that international partners are also going to be getting involved too as well, and perhaps international commercial companies too getting involved. NASA cannot do this alone. It's going to be expensive, very challenging, and so we need the help of let's call it the partners of the United States, to help make this happen. Habitats, habitats are going to be hard to land on the moon. These things are huge. And so how do we land something that's so huge on another planet? Because the issue is the kinetic energy associated with a spacecraft that's very heavy, traveling at a certain speed, and then trying to slow it down so that way you can land something on the moon. It's easier on Mars than it is on the moon because Mars has an atmosphere that you can use aerobraking with the atmosphere that Mars has. Moon has no atmosphere, and so we have to find different ways of landing habitats on the moon. And of course, what we call extra vehicle activity with humans exploring the lunar surface. And of course, there's a lot of challenges with the moon. We got the issues with the moon dust. And the moon dust is very abrasive. It's like glass, small pieces of glass that get on everything. And mechanical systems can break down because of this glass. You got lunar earthquakes, okay? I'm sorry, lunar quakes as we call them. Earth has earthquakes. The lunar surface also has lunar quakes too as well. And of course, you got the radiation effects that we got to protect astronauts. And certainly we got to deal with the 1/6 gravity of the moon. And so if you're trying to drill on the moon, you got to make sure that your equipment can brace itself for drilling because 1/6 of the gravity makes things a lot lighter and more challenging to drill on the moon as opposed to Earth. And so for deep space mission operations, right now, we have, currently orbiting the space station, rather the space station orbiting around the Earth. And so how many people does it take to support space station? Quite a few. So at Mission Control Center here in Houston, where I live and where I work, we have something like 75 people that are basically looking over the shoulder of the astronauts while they're up on space station, because there's over 300,000 and 350,000 sensors on the space station sending data back to the ground. That's a lot of data for one astronaut or two astronauts, even three astronauts to look at. So you got to have more people on the ground looking at that data and seeing if everything is okay. And there's over 100 computers on space station as well. Now, the transmission time of all this information is not too bad because it's only like a quarter of a second, to go from Earth to the station and then back. Very short time, to get that information. Now, on the Mission Control Center, we also have engineers in what we call the mission evaluation room that are also supporting the people in the flight controllers. And in addition to those, we also have people in Russia monitoring a lot of the systems as well. So we have different groups of people, over 200 people, monitoring and helping to maintain the space station. Now let's go forward in time and talk about, the moon, going back to the moon. We're still going to have people on the ground monitoring these systems. It's about 1.2 seconds going one way in transmission speed to the moon. So it's not too bad. Even on Apollo, with the technology they had back then, it didn't take too long for communicating with the Apollo space systems that were orbiting the moon and landed on the moon. But it was still a little bit challenging. The Apollo space capsule had some intelligence on it, not as much as what we have now, but it was enough to help them. But most of the reliance on intelligence came from the astronauts. Case in point, Neil Armstrong, Apollo 11. They were getting ready to land. Apollo 11 was getting too much information. The computers were overloading. And so Neil Armstrong had to turn off the autonomous system to go to manual mode and manually land the Eagle on the moon. If it wasn't for his skills, they could have aborted the mission. And then now let's talk about going to Mars. This is a picture, kind of a notional picture of the Mars transport that would take us to Mars one day. Well, we cannot depend on the Ground Mission Control Center because of the delays in time and maybe the critical events that can happen, something that could destroy the spacecraft. And so we're going to have onboard intelligence, what we call onboard mission control, to help the astronauts operate these complex spacecrafts. And so we're going from a crew mission control center dependent operations to a crew vehicle dependent operations. It's totally new for NASA, and there's a lot to learn, but it's the moon and the Artemis program that's going to help us understand to live and operate on another planet, the moon, and as let's call it dress rehearsal before we go to Mars. So let's talk about human spaceflight mission complexity and the risk associated with that. So the space shuttle, I'll give you an example. This is just a breakdown of the top level pieces of the space shuttle. And so basically the space shuttle had key components, the orbiter, and that's the part that you would see, it looks like an airplane. And then the external tank that provided the fuel for the main engines of the space shuttle. This was liquid fuel. The nice thing about liquid fuel is that you can shut it off very quickly in case something goes wrong. The solid rocket motors, these were the two long rockets that had solid fuel on them. Very dangerous. They were reliable, but very dangerous because once you turned them on, you could not turn them off, not easily. And so it was one of the challenges was to integrate all these components into a complex vehicle that did everything that the shuttle did. Now, let me give you an example of complexity of a system. So here's the space transportation system that included the tank, the orbiter, the solid boosters. Let's just focus in on the orbiter. The orbiter had the avionics system, thermal protection system, the external structure, environmental control system, very important too, and other systems as well. If we go to the avionics system and break that down even further, the avionics system had the command data handling system, instrumentation system. That was part of what I was involved with on Space Shuttle. Communication system, displays and controls. So that's another piece that I was involved with as well. And then if you take command and data handling system and break that down even further, then you look at the general purpose computers, the computers that flew the space shuttle. And it was made up of different computers that talked to the general purpose computers. One of the key ones was the master event controller. And the master event controller was the one that controlled each one of the main engines on the space shuttle. And each one of those main engines had different computer systems and instrumentation systems to let people at the Mission Control Center know the status and health of these main engine controllers. So you can see how complexity increases at a very, very fast rate because of the how complex these vehicles are. And I just wanted to show you how a spacecraft vehicle breaks down, in, especially human spaceflight type vehicles, how it breaks down in complexity. But it's just not the spacecraft that's complex. Orbiter processing operations was a very complex system at the Kennedy Space Center. I used to go there a few times, and I was just amazed how much operations and complexity was there. Computer systems that hook up to the shuttle to monitor the shuttle for the maintenance and operations of the space shuttle was just incredible. Over 10,000 people were servicing the space shuttle in any given day. And then launch operations was just as complex. These structures had a lot of instruments on it, a lot of computer systems, to monitor the launch services, for the space shuttle. And of course, mission control, that monitored the space shuttle once it launched. Mission control had over 75 computer systems, mainframe computer systems, just an incredible amount of communications that's transmitted and received by mission control to the spacecraft vehicle. And then finally, communications. Once everything's up in space, all the communications going on with space station, with the space shuttle or the spacecrafts, as well as Earth. So it's, people say complex systems dealing just with a spacecraft, but it's more than that. It's the complexity of processing these systems, the complexity of launch, the complexity of mission control, and the complexity of communications. And then, but there's challenges ahead. Let's talk about the human briefly. The human needs water. Human needs about 50 liters of water per day, roughly, in order to operate and to keep the body healthy. Oxygen, and of course, to generate oxygen, you need water to generate oxygen for the what we call environmental life support systems. They got to have food, somewhere in the vicinity of 750 pounds a month of food for each one of the astronauts. Sunlight to keep the circadian rhythms of the astronaut in sync. In other words, to make sure that their bodies behave properly, just like here on the Earth, so they can sleep properly and wake up and feel refreshed. And of course, exercise because of the microgravity environment. Got to keep the bones healthy. Got to keep the muscles healthy because the body tends to not produce a lot of calcium when it goes into a microgravity environment because it just sees that it doesn't need to strengthen the bones where there's not a gravity effect on the body. And then, of course, teaming. working in teams. We're gonna have international partners working in a team going to future missions to the moon and beyond. Everybody, all the international partners, come from different parts of the country. They have different belief systems, whether it's religious or whatever. And so you have to deal with the complexity of working and living with people with difference of opinions, and so it can be a challenge. It can be a very strong challenge to do that, working in another world with people. Isolation. People, these astronauts are going to be far away from home, and they're going to feel depressed. They're going to miss their loved ones, and so how do you deal with that? How do you deal with systems? How do you design systems that perhaps the astronaut is not feeling well, and maybe he or she might flip the incorrect button that can cause a catastrophe on the mission? So we need to learn to build better intelligent systems to handle that. And then habitats. Astronauts are going to want to be able to get away from everything at the end of the day and have their own little room, to be alone for a while. And so we need to make sure we build a habitat that helps astronauts, feel like they can, be in isolation for a little bit and have their own time. But at the same time, these systems cannot be so big that it's very hard to land. So that's the challenge. And of course, the radiation environment that can affect humans. Now, let's talk about technology. Technology needs on the moon, but there's challenges too with technology. The deep space testing and deep space validation of these spacecraft systems is going to be very complex. Right now, the thinking is to build them around the moon and then send them to Mars and then bring them back to the moon. And so you build systems just very similar to how we build space station here on Earth, is to build everything orbiting around the planet or orbiting around the moon. So how do we do that? We haven't done this on another planet. We've done that here on the moon, here on Earth, but we have not done this on another planet. How do we do that? Of course, we got to have electricity, to operate these systems. We got to have rovers, intelligent rovers that not only go out and explore by themselves, but maybe carry humans as well, so the humans can go on expeditions around the moon to explore the moon as well. Habitats on the moon, habitats on Mars are going to be important, but we got to design these, to handle not just moonquakes, but also meteor strikes. Meteors still strike the moon. Meteors still strike Mars. So we got to build these systems that are very strong against meteorite strikes. Perhaps we dig underground. Well, if we're going to dig underground, we have to bring big machinery to dig underground. Well, big machinery means you're going to have very good entry, descent, and landing systems, to land something so big on another planet. How do we do that? Environmental life support systems. This is a portable prototype of a life support system that they're currently developing for the moon. And then, as I mentioned, entry, descent, and landing. How do you enter the atmosphere, like, for example, Mars or the moon, with something so big like these habitats? That's going to be a challenge for spacecraft designers. And then, let's see. And then communications, okay, we're talking right now of building an internet on in space, very similar to our Earth. And so how do we do that? Because the communication speeds for deep space is very slow. The best you can do right now is 3 megabits per second from the moon, from Earth to the Mars. We're talking about laser communications. We haven't done it completely, but it can increase it to 30 megabits per second. Still not that fast compared to Earth. And then in situ resource utilization, this is going to be important. In situ resource utilization takes the soil and produces water for the astronauts, because we cannot take all the water that we need on a 2-year, 3-year mission. But it also produces fuel for the spacecrafts. How do we do that? How do we do that reliably given that the soil on the moon and Mars is very abrasive and very difficult to work with. And of course, computer systems dealing with radiation effects. Everything is going to be controlled by computers. And so if these computers do not operate properly, it could upset operations, and it could upset operations for communications. It can upset operations for drilling, upset operations for the habitat. So that's something that we have to think about. And then there's risk. There's the expected system behavior, and then underneath, just like this iceberg, are a bunch of risks lurking in a deep space mission plan that we are not aware of, and we try to do the best we can. And so this is what we call the Swiss cheese model, that basically says you can create these barriers, like, for example, requirements, build a design for the best requirements, the best design, safety reviews, training, maintenance, crew health. But these barriers are not perfect because they're designed by humans. Humans are not perfect. And so you have what we call these little holes in place, that each barrier represents a deficiency or something that's lacking in there. And then you got these barriers that over time, these holes appear in time. And so there's this representation of this Swiss cheese model by James Reason indicates that things line up perfectly for a hazard to create an accident. And that's something that NASA always worries about. And that's why we do all the testing, we do a lot of safety reviews, we do a lot of training to minimize these risks that can happen in space. And so we get involved with systems engineering. Systems engineering is very similar to the scientific method for scientists. Systems engineering is basically a way of methodically designing systems by first defining what the system must do on the left-hand side, and do some prototyping to make sure that you design the right system, and then you build the system and test it to make sure that it was built correctly and that we're building the right system. So it's two things. It's did we build it correctly, and did we design the right system for the mission? That's important. The other important part is, and I was introduced talking about human systems integration, is the importance of the human element involved. What you're seeing here are the domains of places where humans are involved in spacecraft engineering and spacecraft development. So in the center is human factors engineering. This is critical part. This is the part that understands the limitations and capabilities of the human. Humans cannot act as fast as computer systems, and so we have our limitations. Sometimes our thought process is not correct. We forget things. We forget how to operate things. Things like that happen to us, and so we have to train for that. We have to make sure the operations handles human error. And maintenance and support, make it easy for them to repair systems. Safety, making sure these systems are safe even when the humans have done something incorrectly. Habitability and environment, making sure we build these habitats, to house these astronauts and make it comfortable for them during the stay of their long duration mission. And of course, human systems integration, working with systems engineering, making sure that the human element is involved in all different aspects of developing these systems as we progress during the systems engineering development process. And then testing and risk. Designs are not perfect and they're human created. You got hardware system. This is the bathtub model that talks about at the very early stages, what we call infant mortality happens very early in the hardware systems, and then after a while it becomes a constant failure, and then over time, as things systems get older, they start wearing out and errors start occurring. Software systems are not quite the same. Software, you have no parts that fail. And so when you first design software, you have a lot of errors, but then as you test more and more and you get the bugs out, you reduce the failure rate of the software. But if you put new software in, guess what? You're going to have more errors, but then you get those bugs out. and then you upgrade again, more errors, et cetera, et cetera. So the curve for software systems and hardware systems are a little bit different. I didn't put one here for humans because humans have a very complex way of failures, because failures can happen anytime. Uh, Hardware systems and software systems are deterministic. You can predict the behavior of these systems. Humans are not predictable. They're non-deterministic. That's one of the big challenges. Um, Materials and manufacturing processes are not perfect. You cannot, we try to do our best we can when we pick materials and we inspect that material. When we're manufacturing, we make sure that the manufacturing process manufactures good, reliable systems. Assembly procedures and the human are 100% guaranteed to produce an error. You cannot get a technician to be 100% accurate all the time. So you got to watch for that. And then not all development testing at the beginning is the same as verification, validation testing later in the program. What does this mean? This means that early on, you built very simple systems using very simple hardware, very cheap hardware to try to get a feel for is this going to be a problem or not? But then later you start developing more refined systems that are high fidelity, and so the testing becomes even more stringent and more difficult to do as opposed to early development testing. So you have to be able to understand what you learn in development testing may not necessarily be the case later when you're developing or in testing the final flight system. And of course, human error through human in the loop testing. That's what HITL means, human in the loop testing. So human in the loop testing tries to reduce the issues associated with human in making mistakes, that kind of human error. And then skill-based human error. So skill-based is basically you know how to operate the system, but you forget. And then in the mistake human errors is a system that it's kind of new to you and you're still learning. So you can make mistakes too as well. So the whole area, human error, is so important in human spaceflight. And that's why I've recently gotten involved with human systems integration to understand more of the capabilities and limitations of the human in developing spacecraft systems. And then testing ensures a high level of confidence that flaws are captured early and where you can, where it's cheap. You try to capture these issues and errors early where it's cheaper to do than later where it's more expensive. So in conclusion is that we're going to learn to live on other worlds like the moon. We're going to go to Mars one day and even, settle there with humans. And then after we've done this, we're going to be going on to other worlds. And of course, we have to deal with the risk associated with that. All right, so that concludes my presentation. I am going to now return the shared screen back to the folks in the spaceport.
Thanks, George. That was a lovely insight of future missions. So this was really a detailed version. I think everyone must have learned something new today. Yeah. So over to Nehru College, please.
Thank you, sir. Thank you, sir, for the wonderful presentation. It was really informative, and I believe that all students will have benefited from today's session. We are moving on to the question and answer. So, if anyone have any questions, please kindly ask our chief guest. You can put it in the chat box. A very informative session we had. If you have any doubts, you can kindly ask.
Okay. So I see a question on what is HITL, and they didn't quite understand it. So HITL is human in the loop testing. What does that mean? That means that, let's say, for example, we design a control system, display and control system to control a spacecraft. And so to make sure that we design it correctly, we use astronauts to test that system over and over and over again, because the first time that it's designed, It's not right. The software is not designed. The way it responds is not right. And so as the human or the astronaut tests it more and more, they begin to see, oh, wait a minute, this thing is not responding as fast as it could, or this display message does not make any sense to me. Can you make this display message better? So human in the loop testing test out the human interface system to make sure that that system is optimized. That's the word, optimized for the human to operate. Okay, I see a question here. What are the things that we need to develop from this age as a youngster to become part of space organization? So if you're talking about what do you need to do now that you're young, in order to get into space exploration, I'd say, take as, if you're in elementary and secondary school or high school, is to take all the math and science that you can and go on to university and get an engineering degree. I can tell you that so there's this thing about scientists and engineers, and there's a difference between a scientist and an engineer, at least at NASA. Scientists seek to understand nature, and so they study nature and they try to understand how nature is. Engineering is basically we take what we understand in nature and we apply it to develop a solution to a problem. Okay, so engineers build systems, but they use math and science to do that. So as you start in your quest for knowledge and for education, is to take as much math and science, but then when you go to a university, maybe you want to major in physics, but I also encourage you to take some engineering, or major in engineering and take a few physics classes. But my preference is engineering than science, because I'm a person that's hands-on. I want to build things, to do stuff. So engineering does that for you. All right, let's see. In a deep space, can give more information. The satellite Voyager 1, Voyager 2, Telsum 4. Okay. I'm not sure what the question means, but if you're talking about Voyager 1, Voyager 2, they are out. They're pretty much outside of our solar system now. But believe it or not, they're still sending back data, but it's very slow data. Instead of, I used to be like 65 kilobits per second. Now they're sending it at 125 bits per second. And there's a reason for that, because there's more energy in a bit, and so they can detect that bit. For example, if I just say, oh, there's not much energy there, but if I say, oh, more energy. And so that's how they send the information. Very long one, very long zeros. Okay, is NASA having any design or plan in artificial gravity in spacecraft? That's a good question. That's one of the things that's going to be challenging. I can say that right now we're not, because those are very huge systems to develop, very complicated, and maybe not reliable. But maybe one day we will. Maybe India will come up with a simple way of doing that. Let's see. It's kind of hard to keep up with these questions. NASA evolutionary Xeon thruster programming on long ionic propulsion is a future technology. So ionic propulsion is a future technology, but I caution you about ion technology, because we did that on Dawn. Ion is very good for very small, little tiny spacecrafts. For huge spacecrafts, not going to work. We need something bigger than that. We're going to need something like the variable impulse, specific impulse engine that's being developed by former astronaut Franklin Chang Diaz, that gives you a lot of thrust, to send heavy things into space. Nuclear power propulsion, solar electric propulsion. We need things that can send large objects into space. Ion works okay, but for very small things. For the Dawn spacecraft ion propulsion system, it took it almost 4 days to accelerate the Dawn spacecraft to 60 miles per hour in space. Very slow. It just won't work for human spaceflight. All right, I'm not. Let's see. What are the new? Okay, I'm not keeping up with all the questions. What are the new explorations happening in astrobiology field? So I can't. Astrobiology is kind of a new field for space exploration, but basically, this is something that we're looking at for exoplanet exploration. And so, exoplanets is basically planets that one day we'll learn that there's a life form, or that it could support life form. And so, astrobiologists help researchers understand what planets have a environment that perhaps invites life to form there. Let's see.
George, sorry. On this particular question, astrobiology. So recently there was a news on Venus also. In the atmosphere, phosphine has been found, but that doesn't mean that there is a life form like us, we humans, or plantation or anything. It could mean that there is just a small percentage of phosphine. So there are so many things which we need to explore. That's why space exploration, like what George has told, it's really important. Yeah, please, George. Sorry.
Agree. Yes, absolutely. Can you say how you entered NASA and things that you've done in young age to enter NASA? So that's another story. I can spend an hour with that. I never expected to come work at NASA. I grew up in the ghettos of Corpus Christi. My grades in high school were not that great. I struggled at the university. To make a long story short, is that when I did have an opportunity to interview for NASA, I had some experience working as electronics technician and working in manufacturing engineering. And NASA liked that. NASA likes people that have hands-on experience. And so that's important. That's important. And so that's how I got my job. But it wasn't like I was 9 years old and I say, I'm going to work for NASA one day. I thought that was just so far away from reality from me. I just never thought I'd come work at NASA. Anyway, sometimes life is what happens to you while how's that song go? Life is what happens to you while you're busy making other plans, and that's what happened to me. All right. Solar technology is being developed for space missions. Yeah, solar technology is being developed for space missions, but you got to keep in mind that solar energy is very dependent on how much solar energy hits those solar panels. For space station, not a big deal because we get quite a bit of sun. Imagine getting further and further away from the sun. How much solar energy are those solar panels going to get? So that means what? The solar panels grow. If the solar panels grow, how are you going to launch something so huge? So solar energy has its advantages and disadvantages, just like every other kind of energy generation source. What's the qualifications of astronaut after finishing for engineering? How we apply for that? Astronaut, you're going to have a Bachelor of Science usually in STEM, science, technology, engineering, and mathematics. But I have to say that for the United States, you got to be a U.S. citizen, to apply for an astronaut. Not to say it's not impossible. We had an astronaut actually from India that she died on STS-107 on the Columbia. Chawada, I think her name was.
Kalpana
Kalpana
Chawla.
Chawla.
Kalpana
Yeah.
Chawla.
Yeah. So it was a long path for her, but she got to NASA, so I admire her for that. Sir, how did you enter NASA? Write an examination or experience? No, I got into NASA because I interviewed, and so like I said, it was I was interviewed because there was a job opening in engineering, and my grades were okay, but I had a lot of experience under my belt, and that's what really got me into NASA was my hands-on experience. I don't see any other questions, or maybe I missed
Yes,
some.
sir.
Go.
You have one more question, sir.
Okay,
Hello, sir.
thank you.
You have one more question. As you mentioned, a human being in hazardous, then why can't we use robots instead of human being? It's a question by one of the students.
I'm sorry, can you repeat that?
As you mentioned, mentioned human being in hazardous. Human being is hazardous in the space exploration. Then why can't we use robot instead of humans?
Can you use robots instead of humans?
What kind of fucking question is that? பசங்கள்லாம் என்னெல்லாம் கொஸ்டின் போட்டிருக்காங்கடா அந்த நாசாவை தர சுத்த.
Yes, sir. Could you understand the question?
Okay.
Hello.
Samir, can you type that question in?
So what I understood basically is instead of in some of the missions there is a possibility that instead of humans doing it directly, can it be done using robots or some smart AI based robots, just like we have robotic arms, right, for doing so many things. So instead of entering any hazardous environment or anything like that, can we use robots that way?
Yeah. I mean, that's a good question. And so here's the challenge is that humans are, robots can operate in dangerous environments, but they don't have the intelligence. Even though we have AI and all this kind of stuff, the human is still the better person to operate a robotic system. Now, it's not to say that you can have a robotic system that's controlled remotely by a human. And so that's one of the things that they're looking at for the Artemis mission is that you got robots roving around the moon, but orbiting around the moon in the gateway, you got an astronaut that has a what we call a robotics control station that controls the robot from the moon. So it basically protects the astronaut from dangerous extravehicle activity as compared to the robot. But robots are just so far away from our, using artificial intelligence. They're very slow in doing things because of the nature of computations, right? Humans are very good in what we call pattern recognition. I see a person and right away I know who that person is, because I recognize them. For a computer, what do? They got to scan the face, and then they got to analyze it. They got to compare it, blah, blah, blah. It takes a long time, and so humans are much better at pattern recognition than machines. And obviously the other big challenge is that in space, some of the high performance computer systems for graphics, for imaging and all that do not work well in space because of the radiation environment. And that's another challenge that we have for the NASA program.
So someone is asking, what are the possibilities to travel beyond our solar system? Okay.
What are the possibilities to travel beyond our solar system? Well, I mean, we already have with the Voyager, but with no humans on there. Going with humans, it's going to be challenging unless we have better propulsion systems. Think about Voyager, that it took it 44 years just to get outside of our solar system. So if you're let's say you're 40 years old when you leave Earth, you'll be 84 years old when you've left the solar system. So that's why they're talking about colonization, where if we can reproduce in space, that let's say a baby is born when we leave the solar system, the baby would it would be very young, and so that baby eventually controls that spacecraft going to another solar system. But just going from one solar system to another takes a long period of time. I mean, just going to Alpha Centauri at the speed of light, if you're going at the speed of light, which is we don't have the technology for that, takes almost 5 years. Okay, going at the speed of light to Alpha Centauri. So the distances in space are just huge, and we just need to come up with better ways of traveling in space. And maybe one day we'll have like the Star Trek Enterprise, that travels at warp 1 through warp 10 drive, and we're just not there yet because of the physics of that, of traveling as you approach the speed of light. The mass of an object increases to infinity, and I'm not sure what that means.
So There are a lot many questions coming in. So is NASA having an mission for Enceladus, the moon of Saturn?
I know that they're looking at one for Europa
Europa.
because of the because of the water because water has a indication suggestion of some kind of life form. And yes, I mean, you mentioned earlier about there could be different life forms and not, you know, that look like us. Already they're detecting some kind of life forms on the Venus atmosphere, which is crazy because the atmosphere of Venus is very unforgiving and very dangerous, but yet there's something there that suggests some kind of life form. But just think about Earth. You know, in Italy a few years ago, they found in a what they call a sulfuric acid cave life forms living in sulfuric acid. That's crazy. How can things live in acid? But they do. And so we there's so much to learn, and so hopefully we'll find something about Europa, and maybe the life forms are very tiny, but yet we'll learn something new about life forms.
Okay. So the next question is, I will just reiterate the question. It's more about, does NASA believe in alien life on some other planet?
NASA, NASA does not have a let's call it an official position about alien life forms. Um, what they do believe is that there could be potentially some life forms out there, but until we get objective evidence, we cannot say. So the word Carl Sagan said it best. Extraordinary events require extraordinary evidence, and so if you spot a UFO, unidentified flying object, you got to have objective evidence and data to support that this is indeed a UFO. So same thing for extra life forms is that until we get specific objective data that says this is a life form, we're just let's say speculating, and so and NASA does not have a official position of life forms that exist, other than there's a potential for other life forms to exist.
Okay, thank you. So I think two more questions are there, or now three more. So what is the best movie you have watched about space stuff, like Interstellar? They are asking for suggestions.
What is the best movie I've seen for space?
Or maybe you
Uh,
can tell about childhood movie about space of your time.
I mean, from a sci-fi movie, I mean, I enjoy Star Trek, but it's not realistic. Though, Star Trek, we got technology invented because of Star Trek. If you look at the old Star Trek series of the 1960s, the the communicator that opened up and Captain Kirk talked to it, that was invented um, by a telephone company. Star Trek Next Generation, Captain Picard had something that looked like an iPad. Okay, iPads had not been invented, but somebody at Apple had the idea. Hey, how about we develop a something like an iPad that we can just input information? So that and then the tricorder. The tricorder was the military came up with an idea of something like a tricorder that basically monitored heartbeats, and they were going to use this in a battlefield to find out who was alive and who was not alive, just by monitoring the body with a scanner. So I have to say that Star Trek is very inspirational about developing new ideas. But as far as the movies are concerned, I like the one about Neil Armstrong that just came out. Maybe it was 2 years ago. It was realistic. It talked about Neil Armstrong's life and then going to the moon, and so it was very well done. The worst movie in sci-fi, worst movie is called Armageddon. That was terrible. But it was about oil field workers going into space, and it was just crazy. And there was a guy shooting a machine gun on an asteroid, and it was just crazy.
So, Manirathan sir is asking, what about the NASA's view in multiverse concept, say as said by Stephen Hawking? Okay.
Oh, okay. So that's the area of science and physics, and I mean, again, it probably exists, and I'm not going to argue with Stephen Hawkins, but we got to have evidence to show that that's that it's there, and I don't know how you do that. I don't know how do you do that. Einstein's theory of relativity. We can demonstrate that. We demonstrated that on space shuttle. In fact, we demonstrated that. So some theories you can demonstrate, and some other ones that they're still theories until you have data to show that it's real or it's not. But multi-dimension universe is way over my
Okay. There is one question. There is an article that the fungus of Chernobyl nuclear reactor could help astronauts from space radiation. So, what are the possibilities of this discovery, and any research work going on in this field?
Of radiation.
The fungus which was found in the radiation. Yeah, I mean to say, during the Chernobyl nuclear reactor recently, I think the last year there was an article on the fungus which was found in the
The
nuclear
fungus.
reactor.
Okay.
Yeah.
Okay.
So can
the
it
fungus.
can it helps astronauts?
Well, fungus can be bad in space, and so we'd have to understand what kind of fungus grows, and is it harmful or is it beneficial for humans? That's important. The whole thing about radiation, we're talking about radioactive power generation sources on Mars and even on the moon, because how long radioactive material can last. But still, there's some side effects of that. In case of an explosion, astronauts will get exposed to high levels of radiation. But if fungus grows afterwards, if it's, let's say the fungus is eatable, maybe it's a good thing. But if it's harmful for humans, not good.
Yes, correct. So one participant is asking, you have mentioned earlier in your PPT talk that NASA requires help from other enterprises to undertake such enormous missions. What about all the space agencies of the world coming together? What is stopping this from happening? I won't go or take the other part. Uh, what is your take on this?
Well, right now, getting international partnership collaboration not easy. It took a while to get a partnership for space station, and that's because each country has their own let's call it politics of funding money for a particular activity, and so it takes a while to get agreement, and the agreement sometimes has to do with what they want to do and what they want to do versus what NASA would like them to do. And so there's a lot of negotiations going on. Let's say you got 13 countries. They all want to provide a orbiting moon gateway. Well, only one can provide it, but if they all want to do it, you got to say, well, look, how about if you do this piece? How about you? So there's a lot of negotiations going on, and that's a challenge. That's a challenge, is to figure out everything that needs to be done and who's going to do what, and that's where the negotiations comes into place. And of course, the other part is the funding. The country has the funding for doing that, and the let's call it the obligation for doing that too as well.
Okay, sure. So I think there are many questions coming in. Do you still want to continue, or how?
I got time for 2 more questions.
Okay,
Yeah.
so the next question is more from India's perspective, the Vikram lander, which NASA was trying to find out. So, are there any hopes for Vikram lander now, and what steps were taken to recover it from NASA's side?
Okay, you kind of broke up a little bit.
Okay, what I was saying is the Chandrayaan mission, Chandrayaan 2, Vikram lander we could not find Vikram lander. So even NASA was also trying to find Vikram lander. So what do you have any progress or anything about Vikram lander, or we have totally lost the hope?
Yeah, I have no yeah, I have no indication. I have no data on that.
So many 2 3 questions are about area 55 aliens and all. So I would rather okay. There is one last question I would say. So nuclear propulsion can able to use in deep spacecraft. Can we use nuclear propulsion in deep spacecraft, deep mission?
We can, but you have to think about the side effects of nuclear propulsion, especially for a spacecraft that's carrying humans. So, nuclear propulsion require because this gets into a lot of safety issues associated with what can go wrong. And so, what can go wrong is obviously there's a leak in that nuclear reactor. Well, what's going to happen is the astronauts are going to get exposed to that. So, what do? You put this in a containment field. Well, these containment fields are not light; they're huge. They're sometimes made out of iron or made out of lead. And so that means you're talking about something in the vicinity. I've heard 15,000 pounds of just a containment wall to protect the astronauts against that. Well, that's 15,000 pounds that you got to launch into space. And then you have to deal with, how, in case something goes wrong with that nuclear reactor, how do you fix it? You got to have the right protection, to fix a nuclear reactor. I know we have one here at Texas A&M, and Texas A&M University has a heavy ion radiation facility, and whenever something breaks there, they have to clear everybody out, and then these people come in with special suits, very bulky space suits, to go in there and repair. So it's not easy. So there's some challenges with nuclear radiation, or rather nuclear propulsion system.
Okay, I think there is just one last question. NASA is tracking the space debris. Will it be a major problem for spacecraft to launch in future? Is there any solution to collect the debris from space? What are the techniques which NASA is trying to develop to collect these debris?
To correct, well,
To collect these debris, to
debris.
remove debris. Yeah.
Debris.
Remove debris. Okay,
Yeah.
that's another one of those challenges we're hoping commercial partners create let's call it a trash collection space trash collection spacecrafts. That attract debris. It's a major problem, and it's getting worse and worse. If we need to find a solution right now. I mean, NASA tracks debris. Uh, uh, we're looking at ways of trying to collect that debris, but we're actually, I think, for the most part, and I've been to some conferences. Commercial industry is very interested in tackling that problem, and so. But it's not easy. It's not an easy problem. If you think about it, maybe you could, I saw one presentation by a commercial company here in the United States, and they propose launching a spacecraft, and then these little, let's call them little miniature CubeSats, go out and find dead satellites. They attach themselves to it, and then they move it slowly back into the Earth's atmosphere to where it gets into the atmosphere, and then eventually breaks up and burns up in the atmosphere. but it's not an easy problem. It's not an easy problem. So and of course they're looking for money, to fund that too as well.
Okay, sure. So I think we are done with the questions Q&A.
Yeah.
You have a meeting, I guess so.
Yes, I do.
Yeah,
Yeah.
that's okay. Absolutely fine. So over to Nehru College, please.
Thank you, sir, for the wonderful Q&A session. It was indeed a very wonderful session, and thank you for answering all our questions. Now, moving on with this session, I'd like to give a brief introduction about Samir Sachdeva, the founder of Spaceport India Foundation. Samir Sachdeva is founder of Spaceport India Foundation by profession. He's a senior project manager in an IT company based out of Delhi NCR. He loves astronomy, followed by electronics and rocketry, and have been pursuing his passion since the year 2008. He loves doing astrophotography and wildlife photography whenever he gets time from his hectic professional life. Mr. Sachdeva is a national coordinator for NASA Scientists for a Day, the essay contest on NASA missions for schools, executive member of National Space Society, working on space settlement and technologies. He is also the coordinator of IIR's ISRO Outreach Program and Global Hands-on Universe Space Educator. I now invite Mr. Samir Sachdeva to address our gathering.
Sure. Thanks a lot. Just one request, since George has another meeting. George, it's up to you if you want to just leave. It was really very nice session.
Yeah, I gotta go. I gotta prepare.
Yes,
for
I
the
understand.
meeting.
Right.
Yeah.
Right. That's
Thank
correct.
you.
That's correct. So thanks, sir.
Thank you,
Thanks,
sir.
George.
Thanks a lot.
Thanks for lovely session.
Excellent session. Thank you, sir. Thank you, sir.
Thank you.
Thanks a lot.
Thank you,
Bye-bye.
George sir. Thank you very much for
Thank you.
inspiring 1
Thank you.
hour, 1.5 hours with us. Thank you. Thank you very much. Thank you.
Bye bye.
Bye bye.
Sir, thank you, George, sir. Thank you so much for being with us this evening.
Bye.
Thank you, sir.
Thanks
Thank
a lot.
you.
Okay, so I will just continue with my presentation. So again, greetings from Spaceport India, and thanks all for giving us this wonderful opportunity. Whatever, just one request is there, whatever questions which were unanswered, and our team or anyone, George could not respond, just collect them, just shoot out these questions. We will definitely try to answer them, and I will ask George in person also to answer whatever he could. But all these planetary terraform and all, there are different type of scientists who look into all those questions. So that's okay. George will be able to answer everything. So that's absolutely fine. So I will just continue with my presentation, even though it's 7 p.m. So I will just quickly introduce what we are doing and our team and what are the plans. So yeah. So basically, Spaceport India Foundation is a non-profit organization, NGO, which was formed in the year 2018, and it has been approved by Ministry of Corporate Affairs, Government of India. And our NGO is working in STEM education and research work, which is basically stands for science, technology, engineering, and mathematics. So science is a separate topic, technology is a separate topic, mathematics, engineering. So as you all are engineers, even I am also IT engineer. But when we combine everything, then we form this STEM education and research work. So it is something like what George was also telling, from Apollo mission to Artemis mission, you definitely require electronics, aviation, aerospace, chemicals. Chemistry is also required for deep science analysis, whatever missions you are going to accomplish on the moon or the Mars, or rovers are required, mechanical engineers are required. Without programming, if someone has watched Demo 2 mission, where SpaceX and NASA collaborated. So the SpaceX mission Demo 2 in itself, the crew mission, had a lot of artificial intelligence embedded. So everything was programming. but programming without other things is just incomplete, right? So if I don't have a laptop, I don't have a hardware, I cannot do any programming. So science, technology, engineering, mathematics, everything combines together to form a particular product which is helpful to the uh, humans. It could be a different country, it could be a city, or just like navigation is there, weather forecasting is there, satellites are there. So many missions are there. Why we are exploring space to find more life forms, how we humans came to existence. So many questions are there which are unanswered. So that's how STEM education is really important in today's world, even for school kids, or even a toddler, or even for a collegiate, or even a professional. So that's how STEM education basically works, and research work also. So how we started basically in 2015, I mean, I was a part of some private, I won't name them, private international team which was working on Mars settlement. I was given this opportunity to work and analyze nano satellite concepts. We had to build so many satellites, plus where and how these rovers will land on a particular piece of land on Mars. Unfortunately, in 2014-15, I was working on them, but then due to funding issues, everything was from my own salary, I would say. So that's how I mean, there were other team members internationally, so we had to quit due to some or the other engagements. Then in 2015 and 16, I met with this wonderful person whom I will introduce in my PPD, Mr. Craig Kinsman. So we have two Spaceport Indias, Spaceport India Foundation, and one is Spaceport India Africa. We are sister concerns. And the third one we are going to have, planning to have, is Spaceport India USA also. America is already taken for that reason. So Spaceport Africa has done a lot of research work along with Spaceport India. So we have been helping them whatever best we can do in terms of rocketry, or it could be a moon bounce project, or it could be programming also. So in 2017, we started organizing unofficially various space science events in schools based out of Delhi region. Then we further grew. Then I met people like Naveen, Karthik, Varsha, and everyone else. So we kept on growing further and further since then. So in 2018 October, so next month is our second anniversary, Space for India Foundation. So we officially formed on paper, not for profit organization, which acts as a Section 8 company. So we are a non for profit company in a way. We can work across the country, and we can internationally also. We do have a lot of collaboration which we can represent as India. So in 2019 and current during this COVID situation, we have reached out to many cities, including rural and urban areas, and we are also providing free education in the field of STEM. We are trying our level best to increase our team size in different fields and increase our reachability also. So we started initial work for near space rocketry and blueprint for nano satellites also. So I won't go in detail. This is our international collaboration. In India, we are member of Vibha Vigyan Bharati, which has wonderful Indian scientists. The full crew is there, Dr. Harshvardhan, including everyone. So we are members of Vibha Vigyan Bharati, which is a initiative by India also, Swadeshi science in a way. Then I keep on organizing. I like during my introduction, it was said I am national coordinator for NASA Scientists for a Day, which is exclusive for school kids, not collegiates. So the next one is going to start in the month of October. Then again, I will have to judge and shortlist all the essays coming across the country. And our team, Space for India team, is a member of Access Space. Recently, we had a conference with them. We are currently working on space laws, how to have accessibility to their systems and launch satellites at a very cost effective because even a small satellite, a lot of cost is involved. So it will go in lakhs, INR I'm talking about. Then we do have other astronomy related collaborations, including Royal Astronomical Society, which is one of the oldest one in UK. So I will just quickly introduce to my team. So this is our advisory board. Professor R.R. Ilongovan. I think for you guys, we already had one session earlier. That was the first session by Spaceport India. Naveen, my teammate, is there, who introduced Ilongovan sir also. So he is an ex-ISRO scientist, aerospace expert. He has been giving a lot of talks to inspire people, kids around the country. Plus, he has been he keeps on mentoring startups and NGOs like us in aerospace industry. So he's currently working as a professor at KCG College, Chennai. Now, Craig Kinsman, as I told earlier, so he is our counterpart, Spaceport Africa founder, and he is a rocketeer himself and amateur radio electronics expert. So he has done extensive research work in rocketry, stage 1, 2, 3, near space, and he is the motivating factor for Spaceport India also. He kept on asking me and chasing me to have Spaceport India since 2015. So that's how in 2018 finally I formed the Spaceport India Foundation with a very simple perspective that we need to collaborate with kids. As we grow, they also grow in science for all, space for all, basically. So Craig, he has been working on rover prototypes, high altitude rocketry, and high altitude balloons also, amateur radio moon bounce, satellite prototype projects. Maybe in detail, I will take some other session on what exactly we have done and how all these things work. So he is into STEM education and CubeSide open source initiatives. Plus, he is trying his level best to have space maker space facilities in South Africa as well as in India. So, with my help and whatever best we can do collectively, that's how he is working with us. So, he is also working on forming legal partnerships. Then he will form Spaceport USA also in the near future. So the next one is Grant Harkness. He is the director of Wilton Observatory. He is a very lovely, big telescope to which hopefully we will also get remote access. So he is also a president of something similar like we have NGO. They also have TOPS. So basically, the organization or the prolification of space studies. Sorry about that. So he is an astronomer and a meteoroid researcher based out of USA. Plus, he is working on some individual talented kids sponsorship in USA, and he has been sending STEM education kits, including meteoroids, free of cost to many NGOs and educators around the country as well as across the world. So I think third of my courier will be coming soon also. Now coming to Deepak Chaudhary, he's my CA actually. He's aviation and aerospace lawyer. He himself has done BTech in aeronautical engineering, and he has been associated with many corporates, startups, and NGOs. And he is taking up all the top cases of aviation and aerospace laws in Delhi High Court, Supreme Court of India. Plus, he is also a CS of Aeros Club India. I hope you guys are aware, Aero Club of India. So Ministry of Civil Aviation for aero modeling and aero sports projects independently. So he is something similar to me. He is very enthusiastic about space. So I want to introduce myself. Vipul is a co-founder and a treasurer. So basically, he keeps on suggesting something or the other, what needs to be done, how we need to plan, how much funding we have, accordingly we have to work or things like that. So he keeps on sharing all these things. Plus, he is helping us updating our websites. He's a good writer. Plus, all the articles are there. Apart from our team, he is also helping us. So any online newspapers, any promotion is related to anything, so he's taking care of everything. Then we have Naveen from your college. So if Naveen and Karthik, these guys were not there, I don't know where I would be, to be very honest, because I cannot do everything on my own. So he is a thinker, innovator who has helped us shape our organization in 2019 and 20 what we are now since inception. So he has an excellent knowledge of astronomy. He has obviously you must be knowing he has taken many lectures in aero modeling also. He's an expert. So he has keep on giving suggestion. We should have this observatory, that observatory, this location, that location. So he has organized various educational events for schools and colleges representing Spaceport India in South India. Coming to Karthik, he is a science educator and amateur astronomer. So he is a superb expert in physics and astronomy. He has been taking many sessions just like Naveen. So he is also contributing. He is writing various whatever physics we have to teach for various topics to students and everyone. So he keeps on coming up with new ideas of innovation, how to make them understand. So he is working as an outreach coordinator for our organization. Then Eklavya Bhargav is there. He is right now inactive due to some personal reasons. So he is actually acoustic and integration engineer at Astro. So he has moved from Bangalore location to Himachal due to some parents' healthcare issues. So he is working with ISRO and he has actually contributed to Chandrayaan 1 mission, which was in collaboration with NASA. So before actually Chandrayaan lift off, he was doing all the integration testing before the launch, along with obviously other team members. So he has been writing many space-related blogs and articles. So all these others, if I keep on introducing, it will take time. We do have other core team members which are really brilliant, like electronics researchers, an amateur radio, or aero modelers, or PSD, and all that stuff. We do have our kids core team. For we are planning to have kids team also, because this is the right time to nurture their skill set. Anyone who is interested in astronomy or aero modeling, aerospace, or anything STEM related, basically. So this is our current presence. We are expanding. Last 2 years, we have done a lot of good work. So we are going further, and with your help also, of course, we will have more and more initiatives to under our belt. So what we do? Can you just hold on for a second? Sorry. So I hope my voice is audible now. So we have been taking a lot of astronomy and research sessions across the country, be it schools or colleges or even private institutes. And apart from that, we are into astrophotography. We have our own personal telescope and DSLRs. And apart from that, we are also in collaboration with SLU, US-based company. We are doing education outreach in India. So they are providing telescopes remotely that are accessible, and they are really of high resolution. So apart from that, we are into rocketry and nanosatellites. So we design rockets. We work on them. Spaceport Africa is also there. They are experts in all these things. CANSATs are there. Near space HAB is there. High altitude balloons. Apart from that, nanosatellites, which most likely we are going to coordinate apart from other things. So we are into nanosatellites development, blueprinting work is going on. So by 2021 year end October, via SpaceX Falcon 9, we are planning to launch 3 satellites actually. So we are into aero modeling and drones, UAV. So that is one thing. Then electronics and amateur radio, robotics, and we keep on organizing various international events, as I mentioned earlier. So Asteroid Day is there, which is a global event which is appreciated and recognized by United Nations actually. So we are education partners with Asteroid Day, and it definitely it includes beautiful people, astrophysicists like Brian May, who's a guitarist also. And there are other like recently, if you go to our YouTube channel, we have taken a for the first time in India, we have taken a webinar on Asteroid Day with Stuart Clark, Professor Astrophysicist Stuart Clark from UK. So this was one of its kind in India. No one has actually able to get such a astrophysicist of this level, and we are definitely trying to have more. So these are some of the glimpses of our past events, or we are taking more. So now, due to this COVID situations, everything is online. So we are taking webinars. We have started internship in astronomy also. So this is our ongoing work and plan, which I wanted to share with you guys, so that you understand what we are doing and what we are going to do along with you all. So in 2019 and 18 before, we have reached out to almost 100 plus schools and colleges in different cities. We have in person also went there. We have introduced ourselves, what we are doing. Whomsoever is interested in all the STEM based fields, astronomy, aero modeling, or anything. So all these things we have done. So we also won the this asteroid day only, one of the top three international awards to spread the awareness in India about asteroids. And we have conducted various webinars and workshops in the field of astronomy, CANSATs, and other electronic projects. In 2020, this year, due to COVID, we could not do much, but still we went ahead and we started with internship in astronomy. Weekends classes are happening even for a 3-year-old kid or a collegiate. We are taking this, and it is free of cost of initiative for underprivileged and rural area kids. And we keep on giving some of the other discounts also, whomsoever has a request. So slew online telescope, as I told earlier. Then we are planning to start with internship in electronic and amateur radio. There is a ham radio license exam also, which is initiated by Government of India. So we will educate them how to take up this. And one more thing about amateur radio, I just want to take some time, that amateur radio is what is required when you actually launch a satellite. When you launch a satellite, you need a ground station. For that, you need a license. You need to have a location, QoS, and everything. You need to have a setup, antennas and everything. You cannot directly connect with satellite, send or receive, transfer, I mean data. That is not possible unless you have a license in India, or even for that matter, everywhere around the country, around the world. Sorry, even be it USA or anywhere. If you are amateur radio ham license, there are two versions actually. I can give more detail later on. So we will form a Spaceport India Kids Club soon. Memberships are open. This is for small kids actually. So in 2021, as I told, we are planning to work on mass production of reasonable price STEM education kits for research work across the country. Even a small kid or people like you, collegiates, can have this STEM kit. Then we will be the first of its kind to initiate internship in astrogeology, which is outer space geology, just like you asked, Venus exploration, why phosphine and all that stuff is there, and in earth geology, basically. So it will be first of its kind because very few people are actually interested. Then we want to set up innovation lab with your help and everyone across the country for research work for UAV, aero modeling, electronics, astronomy across the country. We are going to initiate private hub for rocketry in India. That's why we have Spaceport India. But then again, it's subject to firework license approval and DGC and everything. So it's a long process in India to get such a license. Then, as I told earlier, with the help of SpaceX Falcon 9, we have a deal with Alba Orbital. It's a startup based out of Scotland. So we will launch 3 nano satellites. Then going ahead, apart from that also, we will anyways in parallel keep on building satellites in-house. So that's where we need innovation labs and everything. We cannot work on our own. We will need everyone's help. So in near future, we want to set up astronomy observatory, or rather observatories and planetarium in India, expand our work across the country in rural and urban areas. If possible, for astronaut training, I'm not very sure on this part. So last part is really dicey, how India progresses. So we are going to plan have space labs, space training, and astro camps, just like what we have in USA or ESA, European Space Agency. But it requires a lot of funding. Plus, we should have such missions. Only then this is going to happen. So this is the telescope which I was talking about. Grant Harkness has this one. So he is still setting up everything. Uh, Main focus now, what we are going to discuss is on Indian space industry and our honorable Prime Minister, he recently announced in the month of May Atmanirbhar Bharat, right? So I mean, since last week, I've been in conference calls, Department of Space, ISRO, Government of India. They have this CIA Unlocking India's Potential, which happened. So I was a part of this webinar. We have been listening to them, these great personalities. Yesterday also, I was in a conference call. So a lot of things are happening, things are changing amidst this COVID-19, but there is a long way to go. Before this, also we had a lot of challenges. Even I personally, being a rocketer, I had to struggle a lot just to look for places where I can launch a simple model rocket, and that too in a restricted area or city like Delhi NCR. It's very difficult to make local authorities understand what we are trying to do. So the recent announcements by Government of India promotes participation of industries. So even Honorable Minister Sitaraman also, she mentioned Indian private sector will be a co-traveler in India's space sector journey. So basically, ISRO has announced that they will provide all the infrastructure what best they can provide, plus space facilities for whatever R&D we want to do. So suppose if I want to launch a personal, not personal in a way, private rocket also, sounding rocket or anything just like SpaceX or Rocket Lab, whomsoever is interested in. So we can leverage that facility, but it is not straightforward. There are a lot many legalities and formalities which we were in discussion about. So, as Honorable Dr. K. Sivan has mentioned, they will empower MSMEs, startups to conduct their own space missions. So that's the motive of this all conference. So this is from snapshot from the yesterday's conference what we were having. So there was a brainstorming session wherein Skyroot and Agnikul and other startups were also there, big ones. So they we were discussing what kind of support is required from the industry for space startups, what is required, what type of infrastructure. It could be financial aid, it could be anything. Then what are the startup policies with ISRO and how the industry can change for us. So till now they have been reserved in their policies. How now privatization will make that change happen. So all these things are yet to be formalized. They are not yet formalized. So they are taking a constructive feedback from people like us or aerospace industry, and then they will start working on that. So they will provide access to ISRO facilities, industrial facilities for a reasonable cost. Focus on innovation that has not been done. So a lot of research projects are there, which might be ignored at times if no proper funding is done or anything happens. So that also is there as a part of this initiative, Atmanirbhar Bharat. So based on standards and qualifications, guidance appropriate will be set up, systems and processes. It's just more of a paperwork, and we need to follow a standard and qualifications. So training program at a reasonable fees, they are also planning for startups. This might take some time, obviously. So resource sharing, as I told, we can use their facility or even lab also. So 3D drawing, design, printing, whatever CAD tools are there that are available. So all these resources will be shared with us, and we can also share with them. So whatever 3D drawings we have created or designs we have created, everything we can share with them. So, and then apart from that, collaboration on materials which are cost effective, there are space materials which come outside the country still. So they are now focusing everything make in India or Atmanirbhar Bharat basically. So even sounding rockets are there, 3D printed, which uses liquid propellant and all. So many things are there which are going on. So I won't go in detail. These are the focus areas of Department of Space and ISRO, like use of green propellant, electric propulsion, so that it does not make that much level of pollution. Every time you launch a rocket, it makes a difference. So that is the main objective right now. So whatever environment and health support systems are there, geospatial, which is actually sensitive information using machine learning and AI, so programming ultimately. like what George also someone asked. So debris management and mitigation, they are now going to focus. So drone UAV is definitely in, and it is the most happening for resource mapping, disaster management. In fact, amateur radios do disaster management in Kerala and Tamil Nadu, or even Assam side. So drones can definitely help. Like they can carry blood donations, or they can carry even a 3D printed liver or heart, or I mean, I'm just randomly giving examples. Many things are there that can be done with the help of UAV. So quantum computing is something definitely that is the top uh, critical priority. I would say quantum computing. Not many are there which are working and thinking from satellite or space perspective. So there are many, but then quantum computing is not that simple. That's what I'm trying to say. So navigation, like our own Navic system is there, application of robotics, AR, augmented and virtual reality techniques, sensors, and there are materials and composites, graphene. So many things are there. Now they are going to focus apart from, along with the industry standards and private companies and startups. So this is I won't go in detail. Only 5 applicants per year will be selected. There is a rigorous application submission and everything, phase 1, 2, 3. Based on that only we can work with ISRO. Otherwise, we are on our on. So we can obviously go ahead with NASA, Falcon, I mean SpaceX or Rocket Lab, but that is a different story. With ISRO, we need to follow this life cycle. They will give more insight when we progress, basically. So last thing, that's it from my side. So what we are looking for is volunteers from your colleges and institutes. We are looking for passionate minded youngsters. So even if we are working on nano satellite, can satellite, experimental rocketry, astronomy research, everything requires, as I told earlier, STEM: science, technology, engineering, and mathematics. So nano satellite, unless programming is not done, it will not work. If Arduino or Raspberry Pi module is not there, electronic objects are not there, programming will not help. So we need electrical engineers, we need computers, we need graphic designers, also CAD, CAM, and all that stuff, mechanical engineers. So there are so many things to be done if we can work together. So yeah, that's it from my side. Thank you. And especially, I would like to thank from my side everyone from Nehru group of institutes, and specifically, I would like to thank JK sir, Karthikeyan sir, for organizing such a good event, and also Mani Rasan sir for organizing the event, and special thanks to P. Krishna Kumar sir. So that's it from Spaceport India side.
Thank you, sir. Thank you for your presentation and for introducing Spaceport India to us and giving more information about your current projects and missions. We wish you all the very best, your success, and may you have a wonderful future ahead. Thank you so much,
So
sir.
thank you. So this success is in collaboration with you all. We will need definitely your support and help to get this done.
Thank you, sir. Thanks a lot. Thanks a lot,
Thank
sir.
you. Thanks all.
Samir, sir,
Thank you.
thank you. Thanks a lot.
Thank you, sir. Thank you, Sandil.
Thanks a lot,
Sir,
sir.
So
Thank you.
any questions? We can
Sir,
take
thank you.
another
Thank you
session
so much,
and
sir.
we can
Thank you.
discuss further. Yeah, sure.
Yes, Samirji, really, you are giving
Yes, sir.
us such a running commentary. Probably, I have noticed, right, for the last 2 hours, I've been keep listening to you. It's nothing but a running commentary, like running in between the wickets, and probably running with the wickets means, I mean, it's a good eye opener for we bowlers. That is the professors and runner professors in my department as well as my students. Definitely, still there's a long way. जरूर कुछ बन जाएगा आपका जो ड्रीम जरूर मिल जाए मतलब बन जाएगा कुछ. Thank you very much. Thanks a lot.
So ultimately, we have to work towards Make in India. Atmanirbhar
Yes,
Bharat, right?
exactly, sir. Thank you, Samir, sir,
Right.
for
Thank
your
you. Thanks all.
comments.
Thank you, sir.
Thank you, sir.
Okay.
Thank you.
Thank you.
Okay. Have a nice day.
Thank you, Samir, sir, for giving us an opportunity
Thank you, sir.
for the NASA engineer.
Thank you. It's my pleasure.
As we have come to the end of the session, I invite Dr. B.R. Senthilkumar Sir, Head Professor, Department of Aeronautical Engineering, to propose the vote of thanks.
Sir, at the outset, it was a wonderful session by George Salazar from NASA, as well as Samir Sachadev from Spaceport. And I thank you so much on behalf of the management, principal, all the faculties of NIET and Nehru Group of institutions, and all my students would have taken a best note of all these informations. And thank you so much for the support, sir. Thank you one and all. Good day. Thank you.
It's always pleasure to work with you all. Thank you. Thanks a lot. Thank you.
Thanks, Ami sir. We will have a separate session. We will have interaction. What are the things we are going to have with our NIT, with the not only aeronautical department, with E.S.E.P. You have to be a tie-up with the entire NIT. That is my request I'm placing in front of you. It is meant for all. Anyway, thanks for your endless support, sir. Thanks a lot.
Thank you, sir. Sir, we are also trying to have our international collaboration and bring technology to India so that we all can work on something or the other for sure.
Sure, sir. Sure, sir.
Thanks, sir.
Thanks a lot, sir. Thanks a lot. Thanks a lot, sir.
Thank you, sir. Thank you.
Thank you, sir, and thank you all for spending your valuable time and exploring with us. Thank you all. The session has now expired. Thank you.
Thank you. Thanks a lot. Bye.
Special thanks to MOC team. Thanks a lot.
Thank you, sir. Thank you.
Thank you, sir. Sir, thank you very much, sir.
Thank you. Thank you,
Yeah,
sir.
thank you, Shavi sir.
Thanks all. Thank you.
Thank you, Samir ji. I'm not finding
words. Thanks to Naveen and Karthik.
Yeah. Thank you, Samir ji.
Thank you, sir. Thank you.
We have to sit across the table to fill up a dream with the help of my student.
Yes, sir.
Namaste. Bahut dhanyawad. Thank you.
Bilkul, sir. Sure. Thank you.
Yeah, thank you, sir. Right. Kind of.
Kanti sir, thank you very much.
Yes, sir. Thank you, sir. Thank you, sir.
For the coordination. Yes, sir. Complete. It's a successful webinar, and we'll take forward along with the guidance of Director sir and Principal sir and our CEO sir. Thank you so much, sir. Thank you.
Yes, sir. Thank you, sir. Thank you, sir.
Thank you, MOC team. Forgot to mention Elizabeth. Thank you so much.
Thank you, sir. Thank you.
Karthik sir, everything okay, sir?
Yeah, sir. Everything was okay, Naveen. Yeah, thank you for you, Naveen.
No, sir. No, not
Naveen,
good. I'm
very good. Thank
sir,
you so much for the support, Naveen. Thank you very much.
Definitely,
Thank you.
sir. Thank you, sir. Thank you.
Thank you. Thank you. Thank you, Naveen.
And
Karthik. Thank you, sir. Thank you. Thank you.
Yes. Thank you.
Karthik,
Yes,
Samar, I've seen you. Karthik, Mr. Karthik, I've seen Samar. I don't know why. In Samar, I met you. I don't know. Fine. Anyway, thanks a lot.
Okay.
God bless you to come up in flying colors on our approach. We should fulfill by the Almighty. God bless you. God bless you.
Thank you, sir.
Thank you, sir. Bye, sir.
Yeah, thank you, sir. We can wind up the session, sir.
Yes, yes. Okay. Thank you.
Okay, sir. Yeah, thank you, sir. Yeah, Naveen, just disconnect the session.
Okay, sir. Okay.
Okay, right. Thank you, Naveen.